Hello folks, my name is Mark Wilson and I'm the founder of AccuModel, where we inspire confidence in hydraulic modeling. This is another video in the tutorial series on Eppanet version 2. In this video we'll be following along with the Eppanet user's manual as far as section by section, and then I'll also post more advanced videos in another playlist. Today we're going to talk about project setup. That's section 2.3 of the user's manual. The first item of setup I want to show you is the project defaults. So when we open up the project defaults, the first tab is the ID labels. Now what happens here is any piece of text that you type in here will be prepended to each automatically generated ID. So typically you'll do something like J dash or J underscore, and then you also need to select an auto increment for the latter part of the ID. So in this scenario our first ID would be J dash 1, and then once we create another one it would be J dash 2, etc., etc. The quick start tutorial in the user's guide indicates that none of those will be used, so we'll just leave that blank. Other property defaults, you can give it a node elevation, tank diameter, height, pipe length. You can switch to auto length, so this will, based on the map defaults that we'll set here in just a minute, will automatically calculate the length. This is used mostly if you've got a background map and you're tracing over the background and you've set it up properly. You can use auto length to generate the pipe length. Otherwise, you probably want to leave that off and get a default and then just change it manually if you're doing more of a schematic model. You've got a default pipe diameter and a roughness. A lot of times what I'll do is choose a more realistic one but put a flag value off to the end, like 119.99. The 0.99 is kind of a flag value. You can do anything like 125.55. It's really the decimal part that kind of gives you an indication that no engineering judgment was used in determining that roughness. But then when you get into calibration, you can round those off and use a more thought out value. As far as hydraulics goes, you've got flow units. This is a very important one to set up in the beginning. This determines whether the model uses SI units or English Standard units. So any flow unit that you choose here that is English will mean that everything else is in English units, such as your length, diameter, etc. One thing to note, that the core unit in Eppanet is CFS, cubic feet per second, and feet. Everything else is that if you choose other settings, it's just converted in the background with a conversion factor. And it's also good to note that the flow unit, this is kind of unwritten. When we're talking flow units, this not only goes for flow in the pipe, but also the demand that you enter in for each junction will be in these same units. So pipe flow as well as junction demand. You can choose from 3 options for head loss formula: Hazen-Williams, Darcy-Weisbach, Chesney-Manning. Typically in the water industry we're using Hazen-Williams. And specific gravity, relative viscosity, those things usually left at the default. Accuracy, this is one that I'll cover in a more advanced topic. This is a good starting space though, 0.001. You would typically try not to go over 0.01 if you can help it. What happens if you get it too high, you're going to get some node continuity problems. So we're going to go and back it off to 0.001. Usually you're only going to have to change that if you have a very complex network with lots of pumps and PRVs that are changing all over the place. Typically I use this stop setting, so if the model becomes unbalanced we want to go ahead and stop the simulation instead of continuing. And this one's a little tricky one, this default pattern. This is something inherent to Eppanet, and it carries over into some other commercial packages like InfoWater, where if you have a pattern with an ID of 1 in the model, any demand that does not specify a pattern other than 1 will take on that 1 pattern, and sometimes that's a little tricky to troubleshoot in certain models. Global demand multiplier, that's a quick and easy way to peak up demands, max day or max month, peak hour, that kind of thing. The other settings here, emitter, status report, check frequency, max check, damp limit. I'll cover those in a future advanced video. Now for view, we want to look at dimensions. So this one allows you to set up what the map area will be. If you don't know what the map area is and you're just doing a more of a schematic model, then this is fine just to pick one, and I guess the map units don't really matter in that case because you can override all of the length values in the model. But if you are going to use a backdrop and trace over the top, you'll want to be a little bit more careful in setting this up and give actual coordinates, whether that be in feet, meters, or lat long. You would set these up more correctly so that when you bring in that background image, everything is the way you want it to be. You can also do an auto size, and it will help you out with that. Last thing is for view options. This is where we would set up how things look in our model, symbology, flow arrows, background color, etc. Well, that's all for now, and thanks for watching. Stay tuned, subscribe to the rest of the video series to learn some more.